Hey, it's Miss Reese, and this is the Unit 5 Edpuzzle test redo recovery. Okay, so we're looking at systems of equations. That was Unit 5, Part 1, and we're looking at systems of inequalities. That was Unit 5, Part 2. So the first thing we're going to be doing is solving some equations algebraically, and so we're solving using this method called the substitution method. So just a reminder, as you're working on your test recovery, you could also have out your toolkit. Looking at the different methods here, we have our substitution method. This was our fall toolkit. So we see, okay, one of our equations needs to be solved for x or y. And then we're going to substitute the expression into the other equation to solve for one of the variables. Let's look back at our question here. So we notice that one of our equations already is solved for y. It says y equals, and we know that y is equal to negative 4x plus 2. So I'm going to substitute that in for y into the other equation. So in the other equation, when I rewrite that, it'll be 3x plus 2. And instead of y, we are substituting that with negative 4x plus 2. And once it's substituted in, we can just solve it like we would solve a regular equation. So we're going to distribute, which means 2 is going to multiply to both terms in the parentheses. So we just bring down this 3x, nothing changed with that yet. And then we have 2 times negative 4x, that is negative 8x. We have 2 times 2, that is 4. And then from here, we continue solving for our variable. We could combine like terms. So if we combine these two, 3 minus 8, that's going to be a negative 5x plus 4 is equal to a negative 6. We can then subtract 4. We're bringing all our numbers to the right side and leave our variable on the left side. So it would give us negative 5x is equal to negative 10. Divide by negative 5 on both sides. And that's x equaling negative divided by negative. That would be a positive. Positive 2 would be our value for x. And now looking back at the equation, we want to solve for our other variable y. We're going to put our answer in x comma y format. We know our x is 2, and now we just need to solve for the other part of our equation. We need to solve for y. So I look at both these equations, and I'm going to pick this one here to solve for y because it's already set up to say y equals. So we can say, okay, well, y is equal to negative 4 times x. Well, we just figured out x was 2 plus 2. So that gives us y equals negative 8 plus 2, which is a negative 6. Okay, so now what you're going to do, you are going to go to Edgelastic. You're going to check your Unit 5 Edpuzzle test recovery, and you're going to do question number 1 here on the Edgelastic. So you are solving for x and y using that same substitution method, and you're going to type your answer in for question 1 on Edgelastic. Okay, then the next 2 questions I want to go over are the special cases. So we'll do question 2 and 3 together, and you're going to try 4 on your own then. So we are setting this up using substitution. So we're going to put this in for y here. That would give us 15x plus 3, and then we're going to substitute that with a negative 5x plus 3 equals 9. So then we would get, okay, 15x, and then we need to distribute 3 into both terms here. So that would give us minus 15x, that's 3 times negative 5x, and then 3 times 3 is 9. And then if I combine my like terms here, that would become 0. So I end up with 9 equals 9. And so remember, that is a true statement. If I were to graph these would be the same exact line. So we would say that this is infinite solutions. And I'll show you the difference between this next question here. So if we look at question 3, now I'm going to use substitution again. I'm going to put this value of y in for y in my other equation. So we've got 9x minus 3. We're going to now substitute in 3x plus 1 for y equals 6, and then we can distribute. So that'll give us 9x, and then we have negative 3 times 3x, that would be negative 9x. Negative 3 times 1, negative 3. And then when we combine like terms here, we're going to get 0. So 0x is just 0. And then we would get negative 3 equals 6, which it does not. This is a false statement, which means that if I were graphing these, they would be parallel lines. This would be no solution. Okay, now what you're going to do, you're going to try question number 4 here on your own. So you're going to use substitution. You're going to input the value of y into this equation here. So I'll start this for you. 4x minus, you want to put this in parentheses and then equal it to 15. So then determine, is there infinite solutions for this or is there no solution? Okay. This next method that we're looking at is elimination. So looking back at your toolkit, good place to always look. In your toolkit, the elimination method, we want to make sure our variables are lined up. We're adding the equations to eliminate the variables with exact opposite coefficients. And then we can solve for the remaining variable. So let's look at this first question here. So our variables are lined up. The x's are here, then the y's in our constant terms. I'm going to go ahead and add these two together, these two equations, because right now I have a 3x and a negative 3x. Those are what we call exact opposites. So 3x and negative 3x are exact opposites. If I add them together, they'll equal 0. So here when I add these two together, I get 0, and I add the y's together, negative 9 plus 7 is negative 2. And then if I add 12 and negative 14 together, that's negative 2. And then I can just solve for my y variable, and I'll get y is equal to negative 2 divided by negative 2. That is a positive 1. Now, once you've solved for one variable, we can solve for the other one. I'll put here my little parentheses. So we solved for y, so that would be here. And now for x, we can plug it into either one of these equations. So we're going to say 3x minus 9 times y. We just figured out y is 1. Equals 12. So that's 3x minus 9 equals 12. We'll add 9 to both sides. 3x is equal to 21. And x is 7. So we'll plug that here. Okay, now going back to Edge Elastic. So you're going to go in Edge Elastic and you're going to go to question number 2. And you are going to type your answer in here for your x and y as a coordinate point. All right, and then we're going to try the special cases for these two problems with elimination. So noticing here, x and negative x, those are exact opposites, and so are my y's. So let's see what happens if we add everything together. X, negative x is 0. 2y minus 2y, that's 0. 2 minus 2, that is 0. So remember, this is a true statement. We would call this infinite solutions when it creates a true statement. Okay, now let's see what happens here. We have exact opposites again. We add these two together. 9 minus 9x is 0. 3y minus 3y is 0. And 10 minus 3 is 7. So then we end up with 0 equals 7, which is false. This is no solution here. Okay, so now go ahead and you're going to answer question 8. You're using the elimination method and determine if they have infinite solutions, these two equations, or if they have no solution. Okay, the next elimination question we have here, if you notice, we have a 5x and a 10x. And I'm just going to focus on the x's for now. And we know that 5 and 10, if I add them together, those are not exact opposites. So in order to make them exact opposites, I could say, well, let's make this 5 into a 10. And let's actually make it a negative 10. If I multiply 5 with a negative 2, that's going to become a negative 10x, and then I will have the other 10x as a positive 10x. Now they've become exact opposites. So then I say, okay, I need to go to my equation that has the 5x in it, and I need to multiply it by that negative 2 to make those exact opposites. Negative 2 here. Sorry, I should have moved that number there. So I multiply negative 2 to 5x to 5y and to the 25. Okay, so I'm going to rewrite it. So negative 2 times 5x is negative 10x. Negative 2 times negative 5y is positive 10y. And negative 2 times 25 is negative 50. And then my other equation didn't change. We've got 10x minus 6y equals 22. So now what we just created, we created equations that have exact opposites. So they didn't have exact opposites to begin with, but now they do. So now we can go ahead and add them together. When we add our x's together, that's 0. 10 minus 6 is 4y. And then 50 minus 22, or negative 50 plus 22 rather, is negative 28. And then if we divide both sides by 4, we would get y equals negative 7. So we've got our y value, which would be negative 7. Then to solve for x, we can plug it into any one of the equations that we have here. I'm going to plug it into the top equation. So 5x minus 5y is equal to 25. That gives us 5x plus 35 equals, that's negative 5 times negative 7 is positive 35. And then we could subtract 35 on both sides. So that gives us 5x is equal to negative 10. We'll divide by 5 on both sides, and x is negative 2. Okay, now you're going to go to Edge Elastic. You are going to type in and solve this equation here. So you've got a 6x plus 3y equals 30, and 2x plus 7y equals negative 26. And you're going to use the same method that we just used. Okay, and then our last type of elimination question here, we've got, if I'm just looking at my x's, I've got a 4x and a 7x. So unfortunately, I can't multiply 4 with any whole number that will make it 7, and I can't multiply 7 by any whole number that'll make it 4. So I actually have to multiply both of these. So I'm going to put a parentheses around both of these, and then I'm just going to flip-flop the numbers. I'm going to put the 4 here, and this will be a 7 here. And then I'm going to make one of them negative, because I want to make, when I multiply 4 and 7 together, that will make 28. And so I want to make one of them positive 28 and one of them negative 28. So I'm going to go ahead and distribute here. That's a 7. So 7 times 4, let's rewrite our equation. 7 times 4x is 28x. 7 times negative 2 is negative 14y. 7 times negative 6 is negative 42. And then we have a negative 4 times 7, that's negative 28. Add negative 4 times negative 5, that's going to be positive 20. And negative 4 multiplied to negative 6 is 24. So now we can add these two equations together. We've got 20 and negative 14. That should combine as a 6y. And then we have negative 42 and positive 24. And that should combine as 18, negative 18. So when we divide here, that should give us y equals negative 3. And once we know our y value, we can then plug that in to solve for x. And I'm going to pick any one of the equations. I just usually pick the first one. So I'm going to type in 4x minus 2 times y. We just figured out y was negative 3 equals negative 6. So then that would be 4x. We've got a negative 2 times negative 3, that is positive 6. We can subtract 6 on both sides. That should be negative 12. Divide by 4, and x is negative 3. Okay, now you're going to try on Edge Elastic question number 4. So you're solving for x and y in these two equations. Okay, now the next thing we're going to look at is graphing. Solve each system by graphing. Let's go back in our toolkit really quickly and look at the graphing method here. Okay, so looking at graphing, I just wanted to review. It's the point, when we graph two equations, the solution is the point where the two lines intersect each other. Okay, so it's the equation or the point that makes both equations true. So noticing here, we've got intersecting lines. And so that would have one solution. There's one point where they cross each other. We have parallel lines, that would be no solution. Or we have like the same exact line, that would be infinite solution. So this is what it looks like graphically. Okay. So I'd like for you to answer this question here. What type of solution is this? Or how many solutions does this have? Okay, now let's try graphing. So just kind of a refresher on graphing. Remember, y equals mx plus b. M is your slope. B is the y-intercept. Remember, the y-intercept is at 0, b. And then just a reminder, a refresher about the slope. You can have a positive slope up to the right, a negative slope down to the right, or you could have an undefined slope, which is a vertical line. And you could also have a 0 slope, which is horizontal. This is my little slope guy. So we'll practice graphing these two equations here. So this first one, m is 3 over 2. And we've got our b value of -4. So I'd have a point at 0, -4. So that's how I graph this first equation here. Start at -4, 0, -4. And then my slope is positive 3 over 2. So positive up to the right. So I'm going to go up 1, 2, 3 to the right, 1, 2. 1, 2, 3, 1, 2. Then you can use like a ruler or a line tool. You're going to be practicing this on Edge Elastic in just a moment. Okay, and then our other line, we have a slope of -x. Well, that's really -1x, so -1 slope. And anytime you just have a number for your slope, you can put it over 1 to make it a fraction. And our b value is at 0, 1. Our b value is 1, so that means our intercept is at 1. So this is where I'd start on the graph, 0, 1, and my slope is negative. Negative is down to the right, down to the right. Down 1, right 1. And if I didn't want to go down and right, I could also go up and left, which is the opposite. Okay, and then what I do is I figure out the point where these two lines intersect each other. So I'm going to let you give me the solution to this system of equations. Okay, for our second graph here, we have y equals x plus 4. So we almost imagine this would be like a 1x. So y equals 1x. Our slope, our m, is 1. I'm going to put that over 1. And then our b value is 4. So we'd have a point at 0, 4. That's our y-intercept. So I'm going to start at 4. And our slope is 1, and it's positive. So up and right. Up 1, right 1. Or down and left is the opposite of up and right. So I can do this as well. So that's our first line. I'll go ahead and graph it. Oops. I'll stick with the same color for that line. Okay, then our other line, our slope is -6, and we can put that over 1 to make it a fraction. Our b value is -3, so we have an intercept at 0, -3. And then our slope is 6, so down, negative slope, down and right. So if I'm going down and right, I'll go off the graph. So instead I'm going to go up 6. 1, 2, 3, 4, 5, 6. Up and left would be the opposite. And then I'll just use a line tool to draw a line through these two. Whoops. Let's see if I can move that. There we go. And move this one a little bit. And then I'd like for you to give me the point of intersection for these two graphs. Okay, now you're going to try this on your own. So go on to Edge Elastic, and you should be now on question number 5. You are going to graph this system of equations. So just remember, you're going to just use this line here, and you can start at any point on this graph, and then you just pick another point to create the line. So just use the slope to help you find another point. So you're going to graph both of these two on the same one here. And then after you've graphed them, you're going to say where those two lines intersect each other. Okay, we're going to practice graphing some linear inequalities. So the first step is still the same. And our first step is still going to be figuring out what is our slope. So our m is 2 here. And our b value is -3. So the point at 0, -3. The only difference is, so let me plot these points. I'm going to start at 0, -3. My m is 2. I'm going to put that over 1. I can go up 2 to the right 1. Up 2 to the right 1. Or I can go down and left. That's the opposite. Now the only difference here is I need to decide what type of shading and what type of line. So I look at this symbol here. This is a less than symbol. And I say, okay, this is my less than symbol. So it's below and it's a dashed line. So I'm going to say below and dashed for this. So I'm just going to create a dashed line. And then the shading for that is below. So I would pick any point that's on the line and then just go down from that point. So then this would be the shading for below the line. Okay. For the next graph, okay, we've got our m equals -3 over 4. Our b value is -1, so we have a point at 0, -1. A reminder with our slopes, so remember our slope guy here is positive. So that's kind of why I knew this one was up to the right or down and left. And then negative. Okay, this is what our line will look like here, negative. All right, tell me what type of line and shading will this graph have based on this inequality here? Okay, so yes, it will be a solid line with shading below the line. So we'll put our first point at -1, down 1, 2, 3 to the right, 1, 2, 3, 4. Up 1, 2, 3 to the left, 1, 2, 3, 4. And then I can use my solid line tool. And then the shading for that would be below the line. Okay, so now you're going to go into Edge Elastic and you're going to try question number 6. Okay, and then just keep in mind when you create a line, let me just show you, like create a random line here. For shading, you would pick an area above or below the line. Oh, and that shades the whole thing. So let me reset that. Let me just make a random line. So if I have the shading above it, oops, do shading above the line, If I wanted to move it, I could just move that dot into the other location here. Or I could just undo, and I could undo and then pick the other area if I wanted. And then also to have your lines dashed, you want to click on this dash and then click on the line in case you do want it dashed. So I'll reset this graph for you. So you were graphing y is less than 2 over 3x minus 4. Okay, and our last type of question, we are graphing a system of linear inequalities. So first thing we would do here is identify our slope as -3. I'm going to put that over 1. Our intercept is at 0, 3. Okay, and for this line, it's a less than or equal to, so then I go here, it's a solid line with shading below. Solid and below. I'm going to start at 0, 3. Negative slope is down to the right. So down 1, 2, 3 to the right 1. So I'm going to use my line tool since it's a solid line. And I know the shading for that is below the line. I'm going to do the shading at the end. For my other line, my slope is, let's use a different color. My slope is -1/2. So this is also negative slope, and I'm going to start at 0, -2. This is a greater than or equal to, so it's a solid with shading above. So I'm going to start at -2, and the slope is down 1, right 1. Down 1 to the right 1. Up and left would be the opposite of that. And that one's also going to be a solid line. Let me use the right color graph line here. Okay, so now for both of these, so we've got one with shading above. So first let me start with my pink line. This line here has shading, I'm sorry, it was solid below. So that's this one here, the pink line. So everything below that pink line. And then we would say, okay, well, let's look at the blue one. The blue line is greater than. So here's the blue line, and it would be everything above that. And then we'd say, okay, well, where is their overlap? And that's where the actual solution is located. So the solution is actually located in this double shaded region here. Okay, so this part here is only shaded for blue. This part here is only shaded in red. So this section here would be shaded everywhere. And so then what I'd like for you to say is which point is a solution to the system. So is it 0, 0? Would it be 3, 3? Or -3, -3? Okay, now for our last problem here, and then you're going to try a system of linear inequalities. We have our slope of 4/3, positive 4/3. So remember that's up to the right. And we're starting at, we have a b value of 3, so 0, 3. And that is a greater than. So greater than, we would say that is a dotted line with shading above. Dotted or dashed. I'm going to start at 0, 3. And I'm going to go up 4 to the right 3, but I can't go up and right, so I'm going to go down 1, 2, 3, 4, 1, 2, 3. And that would go off the graph. And this one's dotted. So let's just do a little dashed line here. Okay, and then our other line, our slope is -1/2. I'm sorry, 1/3. So negative down to the right. And we're starting at 0, -2. That's our y-intercept. And with this symbol, the shading is above, and it's a solid line. So solid above. So we'll start at 0, -2, and down 1 to the right 3. Or up and left would also work. And that's a solid line, so you can use the line tool for this one. Now on this one, I'm going to show you kind of how to do the shading on Edge Elastic, or kind of a strategy you might want to use. So let's look at the blue line first for shading. Now the blue line, the shading is above this line. So I'm just imagining this is where the shading is for that line. Okay, now for my other line, it's also above. So then I would say, okay, well, where I could imagine their shading for both of them would be this region here. Okay, so now I'm going to give you a point, set of 3 points, and I want you to tell me which one is a solution. So it would be 0, 0 is a solution. Let's do -3, 3, or is it 3, 3? Okay, and then you're going to try your last problem here on Edge Elastic. So you're going to graph both of these on here, and then you're going to do kind of that same method where you decide maybe at the very end where you're going to shade, because you really only want it shaded in one region here. So you would almost imagine, like for this problem, you take away that shading, you take away that shading, there's only this shading that's left, the overlapped region, okay? And then, so answer question 7, and then you're done with your Edpuzzle test recovery.